Welcome to Penrose Learning, where we make understanding easy.
You begin by locking down prerequisites and the first actionable steps. Create a virtual environment, pin package versions, and initialize a Git repository so experiments are reproducible. You should pick one clear objective and 2 or 3 datasets that match it, then inspect and document schemas to avoid surprises. Once done, install essential libs, NumPy, Pandas, PyTorch or TensorFlow, and a metrics package, so you can prototype immediately. Make sure to create a small baseline model in the same session to measure progress. You now move into the complex middle steps. Design a streamlined pipeline that loads, preprocesses, and batches data efficiently so experiments run fast. Start with small architectures to iterate quickly, then scale components that work. Use augmentation or feature engineering only when it improves validation metrics. Once you see gains, run controlled hyperparameter sweeps and save incremental checkpoints so you can roll back. Make sure to log training curves and sample predictions. Those visuals tell you why a change helped or harmed performance. You finish by training at full scale and validating on a strict holdout, then export a production-ready model with clear input/output specs. Deploy behind a simple inference endpoint and add continuous integration tests that verify model latency, accuracy, and input validation. Once deployed, monitor performance and drift. If something breaks, reproduce the failing run locally from saved logs and checkpoints to isolate the issue quickly. That troubleshooting step is the fastest way to identify data mismatch, seed differences, or training configuration.
Thanks for watching. If this was helpful, leave a like and consider subscribing. See you next time.